So in this video, we are going to talk about the topics in week 11, some geometry topics, triangles, area, surface area, and circumference. Now, a triangle is a three-sided figure. In a geometry class, it is very common to use that little triangle symbol. So this triangle would be considered triangle ABC, and this triangle would be triangle DEF. And those don't have to be alphabetical. It's just common that you'll see it like that. Now, we know that, yes, it's a three-sided figure, but another thing that you should know is that the angles inside of a triangle always add up to 180. So if you were to add these, 90, 50, and 40, you can see that those total up 180 degrees. So that's a fact that you want to have memorized. Um, if you have similar triangles, the way I kind of think about similar triangles is, let's say that you drew a triangle on a sheet of paper, and it was this size, and you put it on a copy machine and you blow it up to twice the size that it is, or 1.5 times the size it is. So maybe we blew it up and it looks like that. You can see that it maintains its general shape. The angle here and the angle here are the same. These ones are the same. These ones are the same. So what we find is true about similar triangles. The angles are the same and the sides become proportional. This is the similar symbol that you see in a geometry class. So triangle ABC is similar to triangle DEF. So that means that A, since it came first and D came first, those two angles are the same. B and E are the same. C and F are the same. So they are not, they don't have the same size side lengths per se, but the angle measures are going to match. Because if you took a protractor, and again, say we took this and put this on a copy machine and we blew it up or shrunk it down using one of their, the controls that allow you to do that, and printed it out, and we measured this angle with a protractor and this angle with a protractor, we would find they're the same. So the angles are the same and the sides are of equal ratio. So as we see here, this one is double that length. This one is double that length. So they are proportional. So let's look at an example. It says a tree casts a 150-foot shadow. A 5-foot person is standing 140 feet from the tree and casts a 10-foot shadow. What is the height of the tree? Now, I call this triangle, and then this little triangle, sorry, I call them kind of, they're nested together. See how they have this common angle together? And then, we could assume that's 90 degrees and that one's 90 degrees. So we get these proportional, similar triangle relationships. So I'm going to pull out the big triangle. Obviously, I don't have room to make it the correct size, but you'll get the idea. So this was a 150-foot shadow. And then we don't know the height of the tree. But we do know that the man was 5 feet tall and his shadow was 10 feet in length. So we can set up a proportion, okay? So we know that X is to 5, so this is to this, as that is to that. And there's lots of ways to set up a proportion that will get you the correct answer. I'm just kind of showing you what I thought of. So again, start with the bigger one, go to the smaller one. X is to 5 as 150 is to 10. So as long as if you start, if this is the big over little, this fraction should also be big over little. Okay. Now, if we go ahead and solve this, so let me kind of zoom into this proportion. The easiest way to solve a proportion is to cross multiply. So 10 times x is going to be the same as 5 times 150. Now, 5 times 150 is 750. So 10x is 750. So x is going to be 750 divided by 10, or 75 feet. Now, since it's a word problem, I would suggest that you go ahead and you actually, like I've done here, wrote the units out. That's something you want to get in the habit of doing. Okay. So as you can see, the height of the tree is 75 feet. Now, another thing we can notice is the height of the man is half the height of the shadow. So the height of the tree should be half the height of its shadow. So half of 150 is indeed 75. Let's look at this one. Now, in this one, we are just talking about another vocabulary that you should know. The word obtuse. Obtuse triangles have one angle that is larger than 90. So in this one, think about a 90-degree angle is a perfect L. You know, that perfect corner of a sheet of paper, that perfect corner of a wall, okay? So do you see how this would be 90? Approximately, excuse my drawing, but so that would be 90. See how it's the hinge, I think of like a door. It's swung further than that perfect L. Okay. So that is more than 90. So say that was 100 degrees. Now, acute, the word acute means that the triangle has no angles that are 90 degrees or larger. So you'll see that this one, we have a 50, a 65, and a 65. Those do add up to 180. So that is something that you should know. They always add up to 180. But if every single angle is less than 90, it's considered an acute triangle. So I think, oh, what a cute little triangle. Silly, but it kind of works because all of the angles are less than 90. Right triangles, that word right means that we have exactly one, and you can only have exactly one 90-degree angle. The remaining angles are complementary, they add up to 90 degrees. So, if this one was 30, this one would be 60 because this one is 90. And if you notice, that totals 180 degrees. Now, another vocabulary that's going to be important that you know is the word isosceles. Isosceles means that it is a triangle with two equal sides and the equal angles that are opposite those sides. So if you'll notice, let's say that these two sides are equal length. That's the way that you would write it in a geometry class. You would just put those two markings, meaning they're congruent, they're equal. And so these two angles down at the bottom, if we were to measure with a protractor, they would also be of equal angular measure. So these two sides are equal. Their opposite base angles, those two would be of equal measure. Now, there's some things as well that we would be able to tell you. So I'm going to draw over here. If we make a little X, they're called vertical angles when we do that. So if this is 40, this is also 40. And these make a straight line, so they would have to be supplementary or add up to 180. I think we've done that before in a video. So that would be 140. And that would be 140. So when they make an X, really cool things happen. Uh, the two angles above and below the X are equal. The two beside are equal. And these two add up to 180, and these two add up to 180, and these two add up to, so on. Okay. So they've told us that this is 40 degrees. So without really doing any calculation, since we've made an X here, this is 40 degrees. Okay. And so this would have to be 140. This would have to be 140. Now, we also have marked that this side and this side is equal length of 12. So we know that these two sides must be equal. Now, how could we figure out what it is? Well, we know, we'll put little x's here, okay? That's some degree measure I don't know. So we know that x plus 40 has to equal 180. So 2x's plus 40 is 180. We take off that 40 from both sides. We get that 2x's would be 140. So if we divide that in 2, x has to be 70. So let's mark those. So let me take out my x's and let's put 70 here. Now, by that vertical angle rule, when we make an x, the one across from it is also equal. And then these ones have to be supplementary or add up to 180 with the 70 we see there. So 180 minus 70 is 110. So all of these are 110. So kind of interesting how that works. There is a little bit about how, with just a very little information, we can get a lot of information about the angle measures that we see. Let's take a look at this one. Now we know, I'm assuming the way that it's drawn, that this is 60 degrees, this one's 25, and this one is 90. That's your 90-degree mark, that right angle marking. Okay. So what we know positively is that this is 25 degrees. Makes an X, great. Okay. Now this is making a triangle. Triangles always add up to 180 degrees. So we know if we take off that 90 degrees, the other two angles are always going to be complementary, 90-degree total. These two have to add up to 90 so that our total is 180. So 90 minus 25 is 65. So this one right here has to be 65. Now, if we use a similar idea, we have two angles in a triangle. To find the missing third, we can always use the 180 rule. So we already have 63 and 25. We already have 88 degrees. So 180 minus 88 is 92 degrees. So this one right here has to be 92 degrees. So that just kind of gives us, again, a way to find missing angles. So the vertical angle rule, when you make an X, is used quite often. The 180 rule for triangles is used quite often. Now, what's interesting about triangles, only for right triangles, okay, so this has to be a right angle for this to work. You can use something called the Pythagorean theorem. And the most common iteration, the most common version that you see is this one right here. A squared plus b squared equals c squared. So A, B, and C refer to the length of the legs. A and B are the lengths of the legs, the thing that make an L, legs, L. And then the hypotenuse, our longest side, is always across from the 90-degree angle there. That is our hypotenuse. So the sum of the squares of the legs of the right triangle is equal to the square of the hypotenuse. Okay? And so if you just decide to look for leg A, you can see it would just be c squared minus b squared. If you wanted to look for leg B, b squared is equal to c squared minus a squared. So these are just versions of that. You only have to really memorize that top version. So it says a right triangle has legs 8 and 9. Find the hypotenuse. So it doesn't matter which. Based on the drawing, we'll put the little one here and the big one here. So we want to look for the hypotenuse. So I know that a squared plus b squared has to equal c squared. Well, 8 squared is 64. 9 squared is 81. So just total that up. That is 145. Now, that is not a perfect square, so here's what you do. So to get rid of this square, you're going to use the opposite mathematics, which is just that square root. So it's the square root of 145 would be the exact answer. you can't do much to that. If you were to put into a calculator, let's say sometimes the instructions might say round to the nearest tenth or something like that. Um, C is approximately 12. 144, the square root of 144 is 12. So 145 is about 12. So C is around the length of 12. Um, the decimal is like 12.04. So just a touch over 12. Let's do another one. This one says a right triangle has one leg that is 10 and a hypotenuse of 16. What is the other leg? So let's just assume we don't know A. We know this is 10 and we know this is 16. Okay. So let's use the original for a minute so that we know A squared plus 10 squared equals 16 squared. 16 squared is 256. So that's 100. A squared plus 100 is 256. So A squared, we would have to subtract off 100 from both sides. So A squared is 156. So A is the square root of 156. So again, you can't do much to that. If you were to put the square root of 156 into a calculator, you get that it's approximately 12.5. Now, one way to kind of check your work, A and B must always be smaller than C. C is across from the 90-degree angle, so it must always be the largest value. You can see, let me make that look a little nicer. 12.5 is smaller than 16. So there's an example of that. Let's talk about area. A formula that you would need to know is this one right here. The area of a triangle is length times width or width times length. It doesn't matter. They have it width times length right there. So if we want to find the area of a triangle with a length of 10 and a width of 22, the area is just width times length. So 22 times 10 or 220 square units. Now, we don't know in this example whether that was 10 inches by 22 inches, so square inches, or if it was square feet, or if it was square centimeters. So just you can write square units since you don't know otherwise. What about the area of a triangle? The formula you need to know there for the area of a triangle is 1/2 base times height. So let me write that down. So those are all multiplied together, half of the base times the height. The area of a triangle is, with a base of 15 and a height of 12, the area would be 1/2 times 15 times 12. Now, multiplication is commutative, so feel free to do it in any order. But if you do 1/2 times 15 times 12, you get that the area is 90 square units. So that is a triangle example. So what about a figure that is a little bit wonky? Okay. Well, what's nice is if we can break it into figures that we do know, we could find the area. So I'm going to kind of think of, if I chop it right here, I will have a triangle. So I'm going to kind of separate the two. Since this is 18, 18 from 27 is 9. This height it has to be 9. And I know the base is 35. So if I use the area formula, 1/2 base times height, and let's do that math, 0.5 times, or 1/2 times 35 times 9 is 157.5 square units. Now let's do the rectangle we see there, width times length or length times width. It's 35. Oh, it's square feet. I'm sorry, they did actually give the units. So let's write that. You write that like that with a little square next to it. So 35 by 18. The area would be 35 times 18. The area of that rectangle is 630 square feet. So the area total, I'll put a little t there to say total, you would have to add the 157.5 plus the 630, which is 787.5 square feet. Make that look better there. So that is how you can find the area of a little funky shaped figure. Break it down into the shapes that you do know. Okay, so here's a little application problem. It says a 12 by 15 room is being carpeted. The carpet costs $15.95 per square yard. How many or how much does it cost to carpet the room? Now, some things to be concerned about is the units here are square yards and these are feet. Okay, so let's first draw a picture of our room. Now, don't expect this to be pretty. It's just a placeholder for our information. Okay, it's 12 by 15, so just a rectangle that one of the dimensions is 12 and one is 15. Doesn't really matter which. Okay, and so if we think about yards, 1 yard is 3 feet. So it takes us 3 feet to make a yard. So if it's 3 feet to take a yard, if you divide this one by 3, that's 4 yards. If you divide this one by 3, that's 5 yards. And if we use the yards, the area of this, because we want square yards, is 5 times 4, or 20 square yards. So we have to buy 20 square yards. It's $15.95 per square yard. So the cost of the carpet is the 20 we need times $15.95. Well, 20 times $15.95 is a total of $319 for the carpet. So there's a little example of area in a real life application. What about circles? Now, the formula you want to know for circles is this one here. Area equals pi r squared. I'm going to write it here for a minute so we can talk about it. Pi is the number 3.14. Many calculators have a pi button on it. Feel free to use it. It is a little more accurate if you use the pi button than if you use 3.14, but you're going to get very similar answers either way. If in the if in Canvas you're doing a math problem, sometimes they even say use 3.14 for pi. So just follow those instructions. So what you're really doing here is you are taking 3.14 times the radius squared. Now, what does that mean? Well, if the radius is 2, it's 2 squared, 2 times 2. If the radius is 5, it's 5 squared, 5 times 5. In this case, it says we have a radius of 8. So if our radius is 8, that's that length from the center out to one of the edges of the circle. That's your radius. So if the radius is 8, the area of the circle is going to be pi times 8 squared. Now you can do the 8 squared first if you want, following order of operations. So that would be 3.14 times 64, and 3.14 times 64 is 200.96. And it didn't give us the units, so it'd be square units, whatever that happens to. Now, to find the length around the circle. So let's say that we have a circle and we want to put a string around the circle. If we want to put a string around it, that's circumference. So circumference is just a fancy way of saying the outer edge or the perimeter of a circle. And that formula is 2 times pi times r. So again, you're still going to use that 3.14 value. So if they say that same circle we saw above has a radius of 8, what is the circumference? What is the length around the edge of the circle? Again, if you had string and you wanted to put it around there, the circumference is going to be 2 times 3.14 times 8. Now this is just the length of the string around the circle. So the circumference or the length around the circle is 50.24 units, whatever those are, centimeters, um, inches, whatever the length unit happens to be. So that is a little bit of geometry for you. I hope that helps you understand that stuff. You have a great day.